Hi folks, this is a video for Chapter 7, Section 5 on graphing square root and cube root functions. The objectives for today is to graph square root and cube root functions, and we're also going to gain an understanding of how transformations affect the graph of a function. So a little reminder here, good news is with the square root function, we've already seen this way back when. I wouldn't blame you if you don't remember some of this stuff. So we'll just go through and we'll do the whole thing all over again, just to make sure we're on the same page here. So what I'm going to do here is I'm going to make a little table for my square root function, and I'm going to get a bunch of values and plot them and see what we get. Well, I know I can't take the square root of anything that's negative. So right away I can say that my domain for the square root function, by the way, is x has to be greater than or equal to 0. So just a little side note there. So let's get some points. Okay, well, I can take the square root of 0. Well, the square root of 0 is 0. Other values that we should know, the square root of 1 is 1. The square root of 4 is 2. And that's probably all that's going to fit on my screen here. So I'm just going to plot those 3 points. So here's 0, 0. Maybe. Here's 1, 1. Here's 4, 2, and we get a curve that looks like this. So it's kind of a sideways parabola, right? If we kind of let the parabola go the other way, you can kind of turn your head, you can see the parabola there. But the function itself, the square root function, really is just that piece there. And an important little note here, and we'll see this with the cube root function as well, is that it goes up 1 and right 1 to get to that next point, up 1, right 3 to get to the next point. And that's going to help us when we look at our transformations in a moment here. Okay, cube root function. So again, I'm going to make a quick table here. I'm going to take some values that I know the cube roots of. Okay, well I know the cube root of 0 is 0. The cube root of 1 is 1. The next cube roots I know is 8, and the cube root of that is 2. That's going to be off my graph, but at least it'll give us an idea of where it is approximately. With the cube root, we can also take the cube roots of negatives, right? I can do the cube root of negative 1. Well, that's negative 1. The next one I can do is the cube root of negative 8, and that's negative 2. And this list would continue. If you notice here, we get these what are called reflection points, right? 8, 2 and negative 8, negative 2 are both on the graph. So let's see what this does to it. Okay, so here's 0, 0. 1, 1, and the next one is 8, 2, which again 5, 6, 7, 8. It's going to be way out here, really kind of way up there. So we've got this graph that looks like it's, whoops, grab the point. Funny. Looks kind of like that. Okay, and now it's also going to continue down into negatives, right? We're going to have these points here. So negative 1 will be on there. And negative 8, negative 2, again, that's going to be way out here somewhere. So we get this graph that kind of comes down and then flattens out. It doesn't really quite flatten out. It does keep going down, but it definitely gets much, much shallower as it gets out there. So it kind of looks like this square root function, but all these negative values still get graphed, right? So anyways, that's what the cube root function looks like. And we're going to talk about our transformations in regards to these two functions here. So let's do a quick review of transformations so that we get the gist of it. We'll look at this one function here, and then we'll apply it to our other functions as well. So we have a couple things going on here. We're adding 4 inside the absolute value function, which does one thing. We're multiplying by 3 outside the parent function, and we're subtracting 7. So let's take a look at what all 3 of these things do. Well, the adding 4 that's inside means it's horizontal, and it's the opposite of what it looks like. So we're adding 4, so you might be inclined to say that it's going right 4, but that's not what happens, does it? This actually goes left 4. Second thing on our list, if we follow the order of operations, is we have this multiplying by 3 going out here. Well, that's outside. That means it's vertical. And that means it's, and these are my words here, as you see it, not the opposite, in other words. So that multiplying by 3, remember that had the effect of stretching it. So this is going to be a vertical stretch. And we say vertical stretch factor 3 in this case. As opposed to, if this was a fraction out here, like if this is 1/3 out there, we'd have a vertical shrink factor of 1/3. So it's, our factor is greater than 1, so it's actually going to be a stretch. Okay, last thing on our list here is this subtracting 7. Well, that's outside, it's vertical, it's as you see it. This is going to go down 7. So that's our quick review with transformations. We saw this with the absolute value function before, so I thought I would start there. But let's take a look at some other ones here. In fact, I'm going to have you try these first. I know there's a few of them here, but they're pretty quick. You should be able to look at these and pretty quickly determine what the transformation is. There's only one transformation going on in each of these. But the important directions here it's how it relates to its parent function. You don't even need to identify what the parent function is. You just need to relate it to the parent function. So when I look at A here, I see this +4 happening inside, and that's all that's happening. So what does that do? Well, it's horizontal, so it's it's inside the function, so it's horizontal, which means it's the opposite of what it looks like. So this is actually going to go left 4 instead of what you might have thought was right 4. Okay, well, what about B? Well, we have this subtracting 7. Again, it's outside the parent function. Again, notice how I'm not even referencing what the parent function is. We can see it's the square root function, right? We can see that. But it's not really a big deal what the parent function is. We just want to know what are the operations that's going on here. Well, there's a -7 outside. That's simply just going down 7, right? We're just subtracting 7 from whatever our square root function is. Okay, 2 more here. Well, what about this multiplying by 4 outside? What does that do? Well, that's going to be again, it's outside, it's as you see it. It's multiplying, so it's going to be a stretch or a shrink. In this case, a stretch again, factor 4. Okay, what about these next 3? Well, again, different parent function, but that's not really the important part, right? It's really the fact that we're subtracting 5 inside. This is going to go right 5. In E, we're adding 5 inside the parent function, so that's going to be the opposite of what it looks like, or left 5. And then lastly, we have this in F, we have this multiplying by half. It's outside, it's vertical, it's multiplication, so it's going to be a stretch, excuse me, it's actually going to be a shrink this time, isn't it? Because it's a factor that is less than 1. So this is going to be a vertical shrink factor of 1/2. So give yourself a little breather here. We're going to move on. And we're going to go ahead and describe how to get the graph of this function here. G of x equals 2 times the square root of x plus 5 minus 4 from its parent function. And then we're actually going to go ahead and graph it. And I'm going to actually graph this using transformations. So you folks take a moment and talk about, there's 3 things that are going on here, 3 transformations. Can you list them and can you get them in the proper order? So working from inside out, we're going to have 3 things here. The first thing that happens is that plus 5, right? If you start with x, first thing we do is plus 5. That means we're going to go left 5. The next thing that happens is this multiplying by 2. So that's going to be a vertical stretch, factor 2. And then lastly, we have this minus 4 out here, right? So everything's going to go down 4. So the nice thing about this is we can do this point by point, and we can actually try to take the whole graph and do this. I'm going to actually do this, at least start this point by point and see how this goes. Well, I know that 0, 0 is on the graph, so I'm going to follow that point. So this says go left 5. So 1, 2, 3, 4, 5. It says vertical stretch factor 4. Well, that means however high it is off the x-axis or however low it is off the x-axis, go twice as far off the x-axis. That's what that means to do. Well, I'm on the x-axis, so that actually doesn't affect this particular point. The last thing I'm going to do is go down 4. So 1, 2, 3, 4, all the way down to there. So that's where my point 0, 0 went. Okay, let's follow another point. Let's start with 1, 1. And by the way, I know that I can see this is my kind of starting point for my square root function. I know it's probably going to look something like this. I just want to make sure that that point ends up, approximately at least where I thought it was going to go. So let's follow this along here. So I'm going to go left 5. So 1, 2, 3, 4, 5. Vertical stretch factor 2. Well, this distance right here, that's 1 unit off the x-axis. So I need to go twice as far off the x-axis, or to a height of 2. So again, my height was 1 before, now it's a height of 2. And now I'm going to go down 4. So 1, 2, 3, 4 goes down there. And if you notice, I can make this radical function look like this. And we basically have the shape that we want. It's now this is twice as far up right there, right? And then 1 unit across. So there I can see my vertical stretch actually in my function if I didn't want to do this piecewise. I'm going to do one more point just to make sure that I have this right where I want it. I know that 4, 2 was on the graph. So I'm going to start there and do my transformations. I'm going to go left 5. I'm going to go a vertical stretch factor 2, so twice as far up. So I'm going to go to a height of 4. And then I'm going to go down 4, and I end up right there, which is pretty much where I hit it before. I kind of got lucky there because I kind of drew it freehand. But it looks like I did a pretty decent job of hitting that point there. Okay, so these next 2 problems are actually part of your homework. So when I check your homework tomorrow, I'm going to expect to see these 2 graphs on there. And really, you just need to kind of graph what I have here. I invite you to do this before I actually get there, so feel free to pause it here. But I'm sure going to check these tomorrow. Okay, so again, I'm gonna grab my starting point. Again, this is the square root function. So I'm just going to take these transformations one at a time. First of all, I'm just going to write down what they are. So hopefully you see this as going left 2 first. There's a vertical stretch. I'm going to call this a V stretch. Factor 3. And then this is going to go up 1, right? Okay, so this should be a fun one with this vertical stretch. Okay, so let's follow this point. Left 2. Vertical stretch factor 3, well, it's not going to go anywhere off the x-axis. It's going to go up 1. So what I'm actually going to do from here, just to kind of change things up a little bit here, is I'm going to draw the rest of this curve. I know what this square root function looks like, and I'm just going to key in on the fact that my vertical stretch is factor 3. So I know my next point is going to be up 3, right 1. So there's my next point there. And with that, I know it's going to go up like this, and it's going to kind of do something like that. And very quickly, it gets off the graph, so you see what a kind of pain that this one is. But what can we say? It looks something like that. And those 2 points really is enough for me to show, and for you to show that you've got the idea here. Okay, let's do this last one. And then we'll talk about the question that's on the bottom of the page. So notice that this is the cube root function. And what are we doing? We're going left 2. There's a vertical stretch. And a little blast from the past here. That negative out there, remember what that does? That reflects it, doesn't it? This is going to reflect across the x-axis. So let's write down our transformations. Left 2. Vertical stretch. Factor 3. It's going to reflect over the x-axis. This one has a lot to it, doesn't it? And sorry about that, doesn't quite fit in there. And then it's going to go up 1. Okay, so let's see if we can get at least one point or 2 on this. So remember, I'm going to just draw a real quick what this thing looked like before, right? This looked kind of like this. So if you get something that looks like that, obviously it's going to move around a little bit here. So I'm just going to move that out of the way. So I'm going to follow, actually I've got 3 points here, I'm going to follow these 3 points. So I'm going to start with my, I guess they're all going to move, aren't they? And, yep, I don't really want that. Okay, so I'll do 1 point at a time here. So 0, 0, where does it go? Well, it goes left 2. Vertical stretch isn't going to affect this point. Reflection's not going to affect this point either. By the way, that went up 1. But it is going to go up 1. Okay, so that's where my 0, 0 went. Let's see where one of these other points goes. Let's do this one in green. So let's go left 2. Okay, that's right there so far. Vertical stretch factor 3. So this height here, again, is 1, and now it needs to be 3 times as high. So it's going to go up to a height of 3. Notice how it didn't go up 3, it went 3 times as far away. It's going to reflect over the x-axis. Okay, so we had, this was at positive 3 up here, and now it's going to go across the x-axis down to negative 3. So one more time, that was up here at positive 3, it reflects across the x-axis, goes down to negative 3. And then it's going to go up 1, and something's a little bit off here. Oh, this red point here was supposed to be 2 to the left. Okay, that looks a little better. Good thing I caught that now. Something didn't look quite right there. Sorry about that, folks. I know you probably scratched your head before. Sorry about that mistake there. Okay, one more here. I think this might be enough for us to kind of see what's going on here. So I'm going to start at this other point, which was at negative 1, 1. And I'm going to go through the motions here and we'll go through the rubric here that we have laid out. Left 2, vertical stretch factor 3. So 3 times farther away. So this is going to go from negative 1 down to negative 3. It's going to reflect across the x-axis, so it's going to go up to positive 3, and then it's going to go up 1. So something hopefully that you notice about this is the symmetry that we have here. This distance and slope is the same as that distance and slope, which is what we had before with our other 2 points. So hopefully you see that here. And now it's a matter of just getting this sketch ready. So before, when this line here got really shallow, this is actually going to get really steep here. And it's going to go through this point, and it's going to kind of curve like that. It's not the easiest thing to draw. I would say that I didn't do a really great job. But it's got this little kind of kink right in there, right? It's got a little kind of curve right in this area down here. But again, we're going for the basic idea here. So if you don't get this perfectly, don't fret over this thing too much. Okay, so last thought here, we're going to answer this question: what is the domain for each of these functions? There's 2 ways. We'll look at the graphical way, and then we'll look at the actual functions themselves. So the graphical way, here's what I would suggest you do to look at this. Imagine we have a vertical line on here. And what I'm going to do is I'm going to move this across. And notice out here that there's no graph that's being, there's no graph out here, right? So the function's not even defined out here. Well, where's the first part of the graph? Well, the first graph really starts here. We're at negative 2 here, right? So it starts here, and then the graph is actually being graphed all along here and then all the way out to the right. So when you look at it that way, the domain for this function here is x is greater than or equal to negative 2. So that's a graphical approach to it. An algebraic approach, I'm going to get this graph out of the way here because we don't really need that anymore, is, okay, actually you want to look right in there. What can we take the square root of? Well, we can only take the square root of non-negative numbers. So x plus 2 has to be greater than or equal to 0. So if we subtract 2 from both sides, subtract 2, we're going to get x is greater than or equal to negative 2. And that's exactly what we had down here, right? So you got 2 ways of looking at this. You can do the graphical or you can do the algebraic way. So that being said, let's take a look at G over this way. Again, I'm going to get some of this stuff out of the way so this looks a little nicer on our board here. Okay, so I'm going to take my vertical line. I'm going to start passing this through. Now, you can't really see too much out here, but what you need to know is this green arrow keeps going up and it keeps going to the left forever and ever. And same thing with this one here. It looks like it's going down, and it is going down, but it's also going to the left. So as we pass this through, it's really way up here. It's actually going through the function. And it's going through the function everywhere as I go from left to right. Even as I go way out here, this green function down here is really kind of going out that way to the right. It doesn't quite bend like what I did there, but it does keep on going out to the right there. So graphically, we should look at this and say, oh, the domain here is all real numbers. Right? Here's our fancy way of saying this. All real numbers. Or we can just say all real numbers. You can say it either way. If you want to look at this algebraically, the way to look at this is say, okay, well, what can we take the cube root of? Well, we can take the cube root of anything we want to, right? Any real number at least. So I don't need to do any calculations. You just need to recognize, okay, well, what can we take the cube root of? Okay, so just a quick little recap here of what I talked about in this video, and hopefully what you learned in this video is we graphed square root and cube root functions. Hopefully you understand how to graph those, and you know what those look like. And we also we talked about transformations of functions, and hopefully you can tell just by looking at a function what the transformations are going to be and how that affects the graph. So hope you found this beneficial. Have a great day, and I'll see you guys next time.